Which two words when combined contains thousands of letters? If you think you know the answer, just write it down in the comment section and you'll find me there with the correct answer. Anyway, today we're gonna be solving these exponents. The first one, the zeroth problem that we have is x raised to 4 equals to 1. To solve this, we're gonna let 1 to the left hand side. So x raised to 4 minus 1 equals to 0. The next step, x raised to 4 can be rewritten as x squared 2 minus 1 can be written as 1 squared, which is equal to 0. The reason we did that, we want to get the difference of two squares. Now that we have a difference of two squares, we're gonna set it up to a zero product property, which becomes x which is equal to 0. So here we're gonna have minus 1 plus 1, which is equal to 0. This gives us two equations, and our solutions, we're gonna have x minus 1 equal to 0, or x plus 1 equal to 0. Now, for the key moment, on this side we're gonna have x equals to positive 1, and on this side we're gonna have x equal to negative 1. So those are my two solutions to this problem. The first problem that we have on this video, x raised to x is equals to 2 raised to 8. The next step, we're gonna rewrite 2 raised to 8, x raised to x is equal to as 2 raised to 2 multiplied by 4, because 2 times 2 is 2 times 4 is 8. So I didn't change anything there. The next step, x raised to x is equals to 4 raised to 4. So anytime when I have a raised to a, which is equal to b raised to b, therefore a equal to b. In this case, our x is equals to 4. So that's my solution for number 1. Problem number 2. 4 raised to x equals 8. The next step, we're gonna rewrite this 4 raised to x as 2 raised to 2 and x, which is equal to, and 8 can be rewritten as 2 raised to 3. So from here, because we have 2 raised to 2x equals to 2 raised to 3, we have equal bases. Anytime when we have equal bases, we equate the exponents. So the exponent 2x is equals to 3, and for a key moment, x is equals to 3 over 2. Now, most learners may not trust this answer. So, to prove that x equal to 3 over 2 is indeed the real answer, we're going to substitute it back to our question statement, which was 4 raised to x equals to 8. So 4 raised to 3 over 2 equals to 2 raised to 3. 4 can be rewritten as 2 raised to 2. This is gonna multiply 3 over 2, which is equals to 2 to the power 3. So these two are gonna cancel, and we're gonna have 2 raised to 3 equals to 2 raised to 3. That means our answer of x equal to 3 over 2, it checks out. Moving on to problem number 3, which states x raised to x squared equal to 16. So what we're gonna do right here, number 3, x raised to x squared equal to 16. The first step that I'm gonna do, I'm just gonna raise these bases to 2. So I have x raised to x squared raised to 2, which is equal to 16 raised to 2. So the next step, these powers can exchange places. Now I'm going to write x squared, and outside this x squared, which is equal to, now 16 can be rewritten as 4 squared, and the 2 will still remain outside. So from here I'll have 2x squared equal to 4 raised to 4 x squared into x squared, which is equals to 4 raised to 2 times 2 is gonna be 4. So we can see from here, anytime when I have x squared, I have 4 in the base, and then the power x squared equal to 4. So we're gonna write our law of exponents that if I have, anytime I have a raised to a, which is equal to b raised to b, therefore a equals to b. So in this case, x squared equals to 4. So to remove the square sign, we're going to introduce the square root. So the square root of x squared on the left hand side and the square root of 4. So the square root of 4 is going to be plus or minus 2. And the square root of x squared is x. So our answer is going to be x equal to plus or minus 2. You can leave it as it is or write it separately. X equal to 2 or x equal to negative 2. Whichever way, it is acceptable. Moving on to number 4, I have 9 raised to x is equals to x raised to 6. By the way, there are 2 methods to solve this problem. So you just have to choose which one is comfortable for you and the one that you can express in front of the examiner to show them your skills. So the first method that I'm gonna use, 9 can be rewritten as 9 raised to x 9 raised to x. I'm going to raise all these sides x raised to 6. I'm going to raise both of them to 1 over 6x. 1 over 6x on the left hand side and 1 over 6x on the right hand side. From here, I'll be left with 9 raised to 1 over 6 because these two x's are gonna cancel. And on the right hand side, I'll be left with x raised to 1 over x because those ones are gonna cancel too. Now, 9 can be rewritten as 3 raised to 2. Then I still have 1 over 6, which is equal to x 1 over x. The next step, I have 3 raised to 2 multiplied by 1 over 6 is going to be 1 over 3, which is equal to x 1 over x. So anytime I have a raised to a, which is equal to b raised to b, therefore b is equals to a, or a is equals to b. So in this case, x equals to 3. The second method that I spoke about, I can use is 9 raised to x equal to x raised to 6. So from here we have the same problem that you're gonna express differently. So if you are following this, you will see that we can solve this using the other method, which I'm gonna, and 9 raised to x can be rewritten as 3 squared n x, which is equals to x raised to 6 can be rewritten as x squared multiplied by 3, because 3 times 2 is 6. Now we prove this exponential law that if a raised to m and n, this is equal to a raised to n and m. This means these two can swap places, they can switch, so that we have 3 raised to x 2, which is equal to x raised to 3 and 2. They just switch places according to this exponential law. The next thing, to get rid of these two powers of 2, I'm going to introduce the square root sign on the left hand side, on the right hand side, and on the left hand side. So this side I'll be left with 3 raised to x, which is equal to x raised to 3, because after the fluff is gone, this is what I left with. Therefore, according to the laws of exponents, x equals to 3. So that's my solution right there. So problem number 5, I have 4 raised to x equal to 1 over x. The first thing that I'm gonna do, I'm gonna write 4 raised to x and raise it to 1 over x, 1 over x, which is equals to 1 over x. and I'm going to raise it to 1 over x as well. So the next step, 4 raised to x can be rewritten as 2 raised to 2, and these two are gonna cancel, so it's 2 raised to 2, which is equal to 1 over x raised to 1 over x. So we see 1 over x equals 2 on the base, and 1 over x equals 2 on the power. So that means x equals to 2. So from here, just to make things easier for understanding, 1 over x equals to 2. So I'm gonna write 1 over x equal to 2 from here, because you see wherever there is 1 over x there is 2. So 1 over x equal 2 in the power, and on the base 1 over x equal 2. Therefore x equals to 2. So many learners may not trust me with this answer. To prove that x is equal to 2 is indeed the real answer, I'm going to substitute it back to this equation, 1 over 2. So 1 over 2, this 4 can be rewritten as 2 raised to 2. 2 raised to 2. And this 1 over half can be rewritten as 2, because it's gonna come right at the top. Sorry guys, this x is half, not 2. So if I have half here, that's gonna work out, because 2 raised to 2, 4 can be written as 2 raised to 2. So our 2 raised to 2, these two are gonna cancel out and leaving me with just only 1. Then 2 raised to 1 is 2, which is equal to 2. So that proves that indeed x is equal to half is the solution for this problem, because we substituted back x is equal to half to 4 raised to x. Then we got that solution. Moving on to number 6, we have the following problem. 81 raised to x equal to x raised to 12. 81 can be rewritten as 3 raised to 4. And we still have this x outside. So we have x raised to 12 here. To get rid of this 4, I'm just gonna raise all these by 1 over 4. So 3 raised to x into 4, like they've exchanged places, just like in our previous example, equals to x (12). So I'm going to raise both sides by 1 over 4 just to get rid of this 4. 1 over 4. So this side I'll have these two are gonna cancel. 3 raised to x is gonna equal 3 raised to x equal x raised to 3. So from here we can say that therefore x equals to 3. So that's our solution for that one. Number 8, we have problem number 7, we have x over 2 is equals to the nth root of 3. The nth root of x, sorry. The next step that I'm gonna do is just to get rid of this nth root. So x over 2 is equals to x into 1 over 3. The nth root can be rewritten this way. So I'm going to multiply both sides. I'm going to raise both sides to the power of 3. So here I have x raised to 3 over 2 raised to 3, which is equals to just x, because these two are gonna cancel. Now from here I'll have x raised to 3 over 2 raised to 3 is 8, which is equals to x. Solving this further, I'm gonna multiply both sides by 8. Multiply by 8 so that these two cancel, and multiply by 8. Eventually I'll have something like this: 8 over x to the power of 3 is equals to 8x. Solving this further, we're gonna bring 8x to the left hand side. Then we have x cubed minus 8x equals to 0. From here we're gonna factor out x from this because it's a common factor. X, and inside the bracket I'll be left with x squared minus 8, which is equals to 0. So this leads me to two solutions. The first one, x equals to 0, or x squared minus 8 equal to 0. So x squared equal to 8. Then getting rid of the square to the power of 2, we introduce the square root sign, of which x is equal to plus or minus the square root of 8. And the square root of 8 can be rewritten as plus or minus 4 times 3, which can be rewritten as plus or minus 2 root 3. So that's my solution for problem number 7. Now moving forward to problem number 8. I have 4 raised to x plus 4 raised to x equal to 16. From here you can see that 4 raised to x can be factored out because it's common on the left hand side. So 4 raised to x, then inside the bracket I'll be left with 1 plus 1, which is equals to 16. The next step, 4 raised to x multiplied by 2 equals to 16. So I'll divide both sides by 2. Divide by 2. These 2 cancel out. Then I'll be left with 4 raised to x equals to 8. So from here, 4 raised to x can be rewritten as 2 raised to 2x, which is equals to 8 can be rewritten as 2 raised to 3. Solving this, because we have the equal bases, 2x equals to 3, we equate the exponents. So for our final key moment, x equals to 3 over 2. So that's my solution for this one. Now, many learners may not trust my answer, so what am I gonna do? I'm going to substitute back x equals to 3 over 2 to our original equation. 4 raised to 3 over 2 plus 4 raised to 3 over 2 equal to 16. So 4 can be written as 2 raised to 2 multiplied by 3 over 2 plus 2 raised to 2 multiplied by 3 over 2, which is equal to 16. We see these 2 are gonna cancel and I'm gonna be left with 8 plus 8, which is equal to 16. Now you can see that our solution of 3 over 2, it checks out because these 2, they balance. Getting to problem number 10, I see that we have 27 raised to x. It's our problem number 9. 27 raised to x plus 3 raised to x equal to 30. So what am I gonna do is to write 27 as 3 raised to 3 and an x plus 3 raised to x, which is equal to 30. Now I'm going to exchange places just like we did on our previous example. 3 raised to x and 3 outside plus 3 raised to x equal to 30. Now from here we see that 3 raised to x appears here and here. So I'm gonna let 3 raised to x equal to t, so that I have such an equation: t raised to 3 plus t equals to 30. So I'm gonna bring the 30 to this side so that I have t raised to 3 plus t minus 30 equal to 0. Now to solve this further, we're gonna introduce some trick on math of a cubic number. From here, the nearest cubic number is negative 27. So I'll write t cubed plus t minus 27 minus 3 equals to 0. These 2 is still the same as minus 30. I didn't change anything. So we are going to take like terms and solve this. T3 minus 27 plus t minus 3 equal to 0. So this 27 can be written as t raised to 3 minus 3 raised to 3 which is equal to our cubic